Today we're going to begin our second unit, chapter 5. The first unit is going to deal with, and this chapter in general is going to deal with polynomials. In this unit particularly, in this lesson, we're going to learn how to use all the properties of exponents to simplify expressions. That's our goal for today. So make sure you get this down in your notes. Make sure you're copying this down, as we'll be checking them tomorrow. So, let's just start section 5.1. As I said, chapter 5 deals with polynomials, also polynomial functions. Here is a chart that is on page 330 in your book. If you would like to copy the examples from there, it's essentially the same information. But we're just going to go through and give you the names of the properties, the definition, and the example. So if you could copy this down, and if you have to pause, that's okay as well. So, the first property name that we have, and like I said, we're not going to memorize the properties, but be able to use them. Product of powers is called, and you can see a to the power m times a to the power n equals a to the power m plus n. So if you have the same base, which in this case is the base part, it's the big letter, the big number, then the part that's raised, the superscript variable, that's the exponent or the power. If the base is the same and you're multiplying the bases, you can add the exponents. The example I have over here, 2 to the third power times 2 to the second power equals 2 to the fifth power, because the bases are the same. 2 plus 2 is 5. Second property we see here is called power of power property. A lot of people confuse this with product of powers property, and what we do. The power of a power property has, you can see the difference here, there's only one base, and there's something in parentheses. That's how it looks different than the product of powers. Product of powers, there's 2 bases or more. You could have 3 or 4 bases multiplied together and add the exponents. In this case, 1 base, the power of a power property, and the way that it's defined is a to the m raised to the nth power. So now we have 2 different exponents. One raised into the other is the same as a to the m times n. So if we have 1 base raised an exponent and the whole thing raised to another power, we multiply the exponents. An example, x squared to the third power is the same as x to the 6th, because 2 times 3 is 6. So we can use the first 2 properties are often flip-flopped at times, so be careful when you're applying these in your problems. The power of a product property. The power of a product property says a to the b to the m equals a to the m times b to the m. So what that means is if I have 2 bases being multiplied, 2 values being multiplied in parentheses, and the power on the outside, I raise each of those bases to that power of m. Well, in other words, I kind of think of this as distributing, because this n, we think about, something in front of a parenthesis being multiplied by everything inside, the distributive property. This is kind of the distributive property of powers. But we're only multiplying or applying it to the exponents of each base. So if you look at the example, 3x to the third, the 3 goes to the base of 3, and the 3 goes to the base of x. So 3 to the third times x to the third, and we can do 3 to the third in our calculator. 3 to the third is 27. 27x to the third power. Negative exponent property. So if we have a negative exponent, in this case a to the negative n, as defined here, is the same as 1 over a to the n. So in other words, a negative exponent flips a base to the bottom. Or if you had a negative exponent, you theoretically could have it in the bottom of a fraction, in the denominator, and you flip it to the top. The negative exponent flip-flops the base from where it was to either the top or the bottom, depending on where it starts. So for instance, x to the negative 5, it's a negative base, or negative exponent, excuse me, so it flips to the bottom and becomes 1 over x to the 5th. And the zero exponent property, the 0 exponent property, here we go, a to the 0 equals 1. Anything to the 0 power is 1. A billion to the 0 power is 1. A trillion to the 0 power is 1. Negative 5,000 to the 0 power is 1. 10,000 to the 0 power, try to put it on your calculator. Anything you put to the 0 power is 1. And the quotient of powers. Quotient of powers, that's the second to last one we have here. Quotient means fraction. So a to the m divided by a to the n, we notice that we have the common base on the numerator and the denominator of the fraction, the top and the bottom. So if we have a common base, what we can do is we can separate, we can put this together, and we can subtract the top base, the top exponent, minus the bottom exponent. So say that again, a to the m over a to the n equals a to the m minus n. Top power minus the bottom power. I have an example over here. 2 to the 5th power over 2 to the 3rd power is 2 to the 5 minus 3. A little bit better, 5. 5 minus 3 equals 2 to the 2nd power, which of course can then equal 4. Last property we have on this slide is the power of the quotient. Quotient, once again, is still fraction. So very similar to the power of a product property. If I have m outside of the parentheses and a fraction inside, I simply can distribute that m to the numerator and denominator terms to simplify the expression. So by definition, a over b, all raised to the m power, for all in parentheses, is the same as a to the m over b to the m. The example I gave here is x over y squared is the same as x squared over y squared. So just if you didn't get any of those, go ahead, pause, rewind, go back, get them all written down, and we're going to apply them on examples on the next slide. Excuse me. So on this next slide, you can see we have several examples to practice. Feel free to pause right now if you'd like to and try these examples on your own and then compare the answers as I go through them. So first example, we've tried all these. The first example, 6 squared to the 3rd power. Well, you see parentheses here. So one thing inside, that means we can distribute that power to the 2. We get 6 to the 2nd power times 3, which is 6 to the 6th power. Okay. Of course, on your calculator, you can type that in and get a number. Okay, so if I want to check and see what 6 to the 6th power is, the power key is the little button above the division sign. 6 to the 6th power is, stuff out of the way. 6 to the 6th power is 46,656. Next one, this is a fraction, quotient powers. We have the same base, a base of 4 on the top and the bottom. The property, if you look back in your notes, says you can subtract the top exponent minus the bottom exponent. So 4 to the 5 minus 3 is 4 squared. You don't need a calculator for that one. 4 squared is 16. 7 to the negative 4th. That's a negative exponent. The rule says I can flip that and make that 7 to the positive 4 in the denominator. And if I really wanted to take that out, once again, 7 to the 4th is 2,401, so that would be 1 over 2,401. Negative 4 to the 2nd times negative 4 to the 3rd. Well, they have the same base. We're multiplying them together. We can then do what? We can add the exponents. So negative 4 to the 2 plus a negative 3. So when we add these exponents, we get negative 4 to the negative 1. Well, do we leave it like that? No, we can't. The rule is we cannot leave negative exponents. We do not have negative exponents in the final answer. So this is the negative exponent property. 1 over negative 4 to the 1st power, or just negative 1/4. is our final answer. So yes, in some problems we're going to use more than one property. Don't just think one property and you're done. A lot of the problems you'll use multiple properties. Last one, we have a fraction with an exponent on the outside. We can distribute that power to the numerator and the denominator. 2 to the third over 9 to the third, which would be 8 over 729. You type that in your calculator. Okay, so hopefully it matches up with what you got. And we'll keep practicing on the next slide. One more thing before we move on. Obviously, these are all numbers, right? I could put these problems in my calculator to check and see if I get the same number. So for instance, let's just look at B, 4 to the 5th over 4 to the 3rd. I could use my fraction app, math, alpha y equals, excuse me, is the 4 to the 5th power over 4 to the 3rd power. And I get 16. So obviously, if it's all numbers, do you really need these properties? No. But I'm giving you these because you can check and see if you've got the same answer. You can put it in your calculator in a way and get an answer, and then practice the properties. Because guess what? Next slide, we're going to be dealing with variables as well. And there's no shortcut or cheater way to get around it, so to speak, if you don't understand the problem. So just the numbers are just kind of practice to see, check your answer to see, make sure you're doing it correctly for the next slide. As promised, variable expressions. X to the negative 6 times x to the 5th times x to the 3rd. These are all the same base. They're all bases of x. We'll have a base of x. When we have the same base and we're multiplying, we can write them as one base and add the exponents together. So negative 6 plus 5 is negative 1. Negative 1 plus 3 is 2. This all comes down to x squared. So notice you can't really check it on a calculator. How could you check it? You could pretend. Pretend x equals some number, let's say x is 2. Well, if x is 2, we can say it is 2 to the negative 6 times 2 to the 5th times 2 to the 3rd. Does it equal 2 to the 2nd? So we evaluate each side individually. Let's look at the left side. 2 to the 6, or excuse me, negative 6, times, let me hit that right arrow to get on the power part, 2 to the 5th, times 2 to the 3rd. And we get a number, we get 4. 1 is 2 squared. I hope we don't need to calculate for it, but just in case, it's 4. So then we get the same thing. They both simplify to 4. Now, does that prove it and it works for one example? No. It doesn't prove it. Just make sure one example works. It has to work for all numbers. But it's not feasible to test every number. So test 1 or 2 numbers and make sure it works when you simplify 2. And that's kind of a way we can possibly check it. Because we can't just plug x into our calculator and we have it work. Okay, once again, I want you guys to try this example. You guys do that before, pause it and send you on it that you're going to try it first. And when you're ready, hit play and see if you have the same thing. Okay, so what does it mean when two things are by parentheses or in parentheses next to each other? It means they're multiplying together. So we're multiplying 7y squared times 8y to the 4th. So we can rearrange some things. If we're multiplying, I can multiply in any order. So I'm going to multiply 7 and 8 together. Switch the order. And I'm going to multiply y squared times y to the 4th. Why? Because when I do this, I can multiply 7 times 8. 7 times 8, you didn't need this class, I hope for that. It's 56. Y squared times y to the 4th, we do need the properties we just learned. And it's just, they have the same base. So what do we do with the exponents? We add them. 2 plus 4 is 6. So 56 y to the 6th power would be some financial. I hope you get that one as well. I'm going to quick pause it. Try C on your own, please. A to the negative 3rd. This one's a negative exponent property. We just flip it, it goes to the bottom, we get 1 over a to the third. So these properties still work with variables as well as with just number values as well. Here's some more practice. Please take the time to write these down, try them on your own before you watch me do it. See if you have an idea of what you're doing. When you're ready, hit play. Okay, so we see an expression on the top and an expression on the bottom, or an expression in the numerator and an expression in the denominator. So what we can do to simplify this is we can kind of group like terms. What I mean by like terms, 8 divided by 4. We can have 8 divided by 4 times the t's. T to the third over t squared. And finally, v to the fourth over v. And why did I do that? Because I can simplify using the fraction or the quotient rule, and we can kind of just reduce each fraction, so to speak. So 8 divided by 4, once again, hopefully you don't need this class for that, but 8 divided by 4 is 2. T to the third over t squared. What do we do when we have like bases and with the exponents? We subtract them. T to the third, 3 minus 2, and same thing with v. V to the fourth over v. Do not tell me that that is v to the 0. What is that power? It's v to the 1. If you don't see a 1 there, it has to be. Otherwise, if it was v to the 0, we would just write 1. V to the fourth over v to the 1. 4 minus 1, and obviously this simplifies to 2. T times v to the third. That would be our final answer for that problem. For E, we're going to try that. Pause and try this one now. Okay. Hopefully you've tried it. At this point, remember we just did one like this. 2 parentheses next to each other means multiply. 3, and there's a 1 there, so we have the 3, I guess, is going to be by itself. The m's I'm going to put together. M squared times m to the negative 2. And the n's I'm going to put together. N to the 5th times n to the negative third. Because all these, when they're right next to each other, means multiply. And I can multiply in any order. We learned that in middle school, and we reinforced it in Algebra 1, which you might have learned in middle school as well. So let's look at these. 3 is not going anywhere. 3 is there. M to the 2 times m squared. Same base. We add the exponents. 2 plus negative 2 times n to the 5th times n to the negative 3. That's 5 plus a negative 3. And now we just simplify the m's. M to the 0, n to the negative 2, or excuse me, n to the positive 2. Do we leave it as m to the 0, I think? What is m to the 0? M to the 0 is like anything to the 0, it's 1. So this is 3 times 1 times n squared, or just 3 times n squared. Last 2 practice problems for this lesson. Once again, we have a fraction. Excuse me, before I keep going, pause this. Try them on your own first. These are more challenging. There's multiple steps in these, so don't worry about it. Give it a try, and then come back and check your work when you're ready. Okay, so we have an exponent outside the parentheses. That means it can go to each term on the numerator and the denominator. So I really have s to the third squared, and I have t to the negative 4 squared as well. So now we can see we have the numerator and denominator. We kind of have to treat separately for a minute here. I have power of a power property going on the top and on the bottom. What do we do with that? We multiply. So the moral of the story is if there's already a power with these terms inside the parentheses, they're going to get multiplied. So do 2 times 3, not 2 plus 3. So we get s to the 3 times 2, which is 6. And we get t to the negative 4 times 2, which is negative 8. So we leave it like that. We don't. We can't have a negative exponent. So what happens if a negative exponent's in the bottom? Well, we turn it to a positive and we move it to the top. Remember that? I kind of called that the flip-flop rule before. If it's on the top and it's negative exponents, it goes to the numerator, excuse me, denominator or the bottom. If it's in the denominator or the bottom with a negative exponent, it moves to the top. So s to the 6 times t to the 8 would be our final answer. Last example, please try this one on your own as well. Okay, so we got lots of things going on here. There is more than one way we can do this. We can distribute this power to all these terms right off the bat like we had before, or we can try and simplify what's in the parentheses first. I'm going to start by simplifying what's in the parentheses first. Because I see that I have an x to the 4th over x to the 3rd, which I can simplify, and I have a y to the negative 2 over a y to the 6th that I can simplify. Still all being raised to the 3rd power. Now, why did I do that? I can use the quotient rule and I can subtract exponents. X to the 4 minus 3 times y to the negative 2, excuse me, minus 6. Let's try that again. Y to the negative 2 minus 6. All being raised to the 3rd power. 4 minus 3 is 1. So x to the 1st power times y to the negative 8, all being raised to the 3rd power. And we got more than one way we can go here. I'm going to get rid of the negative exponent right now. To do that, I would move the y to the 8th at the bottom, so I have x over y to the positive 8, all to the 3rd power. And now, last but not least, I'm going to distribute that 3, and I get x to the 3rd over x to the 24th power. So, is that the only way we could have done this? No, we could have chosen a different order. Maybe you wanted to distribute right off the bat. You could have done that, distributed 3 to all the terms. Maybe at this, did the same thing I did, but at this step you distributed when it's x times y to the negative 8 to the 3rd. Maybe at this point you chose to distribute. You know, you could have done that. So there is more than one way to do it. You may have done the exact same steps in the exact same order, but as long as you use correct steps and ended up with the same answer, then you did just fine. So let's look back at our goal for the lesson, our target. After this lesson, I'll be able to use all the properties of exponents to simplify expressions. I hope that you feel that you can. We went over a variety of examples. We will do some more work with this tomorrow in class. Please bring your notes. Have them ready to be graded as you walk through the door. Have a good day.